In this video, we'll be looking into the conversion of Epsilon NFA to DFA using Thompson's construction method. Firstly, we need to understand what Epsilon NFA is. So, Epsilon means without reading an input signal, the transition can happen from one state to another. So, an NFA consisting of such epsilons can be constituted as Epsilon NFA. Epsilon NFA is also called as null NFA or NFA lambda. So yes, and one more characteristic in this topic is that we'll be using a topic called epsilon closure or E closure or null closure. All these constitute of the same. So let's solve the problem now. So here we will be using Thompson's construction method. Fine. So this is the epsilon NFA given. So firstly, we need to obtain, our first step would be obtaining the transition diagram of given epsilon NFA. So let's draw the transition diagram. So there are three states here, that is P being the start state, then we have Q followed by R being the final state. Okay, so P epsilon gives phi. Okay, so there's nothing here. So P of A gives P itself, fine. P of B gives Q, and P of C gives R. Q of epsilon gives P, Q of A gives Q itself, and Q of B gives R, and Q of C gives null. Okay, so R of epsilon gives Q, and R of A gives R itself, and R of C gives P. So this is the transition diagram obtained from the given epsilon naught NFA. So our next step would be to obtain, step 2 would be to obtain the epsilon closure of all states. Here there are three states majorly, that's PQR. So epsilon closure of P is P itself. Epsilon closure of Q and epsilon closure of R. So any state, if you have to find the epsilon closure, so that state itself would be there first. Q and R will be there in these two. Followed by that, we have to check if there's any transition happening when epsilon is there. So in P, is there any transition happening when epsilon is there? No, it's not happening. In state Q, check if there's any transition happening on epsilon. Yes, it is changing to P, right? So from Q, it's changing to P, right? So Q comma P. And now check in R. So in R, is there any transition happening from epsilon? R, epsilon Q. So from R, it's going to Q, and from Q, it is going to P. So you can write R, Q, P. So here you need to consider the continuous path, which is continuous path or continuous transitions happening during the state of epsilon. So RPQ can also be written as PQR. Let's write it in a understandable order. Now let's consider the start state, that is P, right, and finding the epsilon closure of P. Epsilon closure of P is P itself. So we'll take P as A. A is equal to P. We'll take this as a constant A. Okay, so A is equal to P. Now finding transition of A on small a, transition of A on B, and transition of A on C. So I hope you understood this step. So you are taking epsilon closure of P, that is P, as A. A is equal to P. Now you will find the transitions of A on A, A on capital A on B, and capital A on C. So first A on A. Epsilon of A on A will give P itself. Epsilon of A on B will give Q, and epsilon of A on C, P on C. P on C will give R. So we have found the transition function values. Now let's write the epsilon closures for all of these. So epsilon closure of P, epsilon closure of Q, and epsilon closure of R. So for P it is P itself, as we have seen here. For Q it is P comma Q, as seen here, and for R it is P, Q, and R. This P is same as A value, right? A is equal to P. So let's write A here. PQ is something different, so we'll represent it by constant B, and PQR will represent it by constant C. Now our next step would be taking B is equal to P comma Q. So we have taken B is equal to P comma Q. Now let's write the transitions of this constant B on A, B on B, and B on C. So B on A, B is PQ. PQ on A is PQ itself. PQ on B would be QR. And transition of B on C is R. Now writing epsilon closure of PQ, QR, and R. We know the epsilon closure of P and Q comprises of P, Q, and P, which can be written as PQ itself. Here it is P, Q, and R, and here also it is P, Q, and R. So PQ is similar to B, yes. PQR is similar to C, and here also it's similar to C. Now we have found out the transitions of constant A, constant B. Now constant C is remaining. So let's write the transitions for constant C also. Let's take C is equal to PQR. Okay, so now we'll write transition of C on A, transition of C on B, and transition of constant C on C. We'll find it out. So C comprises of PQR. So PQR on A gives PQR itself. PQR on B gives QR. And PQR on C gives PR. Now finding epsilon closure of PQR, epsilon closure of PQR, we get PQR only. Epsilon closure of QR, epsilon closure of Q and R, we get PQR itself. And epsilon closure of PR, we get the same PQR. So this is the same as C, constant C, constant C. So we need to continue repeatedly doing these steps until and unless all the constants here are defined on the sigma values whichever we take. So our next step would be, step 4 would be to draw the transition table for DFA. So DFA, transition of DFA on A, B, C, and the states here taken are capital A, B, and C. So capital A being the start state and capital C being the final state. A on A is A only, A, B, C. So it will be A, B, C. Then we have BCC, B, C, C. Then we have C, C, C. So writing the transition table is very easy. Our next step is to draw the transition diagram for DFA. So let's draw the transition diagram, which is very simple. A, here we have B, and here we have C. So transition of A on A gives A itself, A on B gives B, and A on C gives C. Transition of B on A gives B itself, B on B gives C, and B on C gives B on B gives C, and B on C also gives C itself. And transition of C on A, B, C gives A, B, C, C itself. So here we have written the transition diagram also. So I hope you have understood how to solve questions of Epsilon NFA and its conversion into DFA using Thompson's construction method. If you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.